So we started with the API management, and in previous classes we have seen like what exactly is meant by APIs, and in APIs then we saw what is an API provider, what who is an API consumer, what is a service. So all these things we saw in the in like previous classes. Now, when the API works, they works in two types of modes. One is the request-driven architecture, and the other is the event-driven architecture. And in the event-driven architecture also, there are two types of variants: push variant and pull variant. But first, we will see what is a request-driven architecture. So, before we start about request-driven architecture, you should know that there are two types of APIs. One is synchronous, the other is asynchronous. So when it is a synchronous API call, which means that one system is sending a request to target to a consumer, and then the consumer is sending some response back to the source, to the provider. Whereas in the asynchronous calls, the provider will send a request to the consumer, but there will not be any response back to the provider. So let's say that you have done some transaction, like there is an API which has been triggered to the target system or to the consumer, and then the provider is expecting a response back from the consumer. So these type of calls, they are called as synchronous communication. So in a request driven architecture, there is a one to one communication between the service provider and the service consumer, which means that the provider will send a request to the consumer and consumer will send a response back to the provider. This is called as request driven architecture. And this maybe, let's say, an example of request driven architecture. Let's say that there is a SOAP request, and this is the example of a SOAP request that there. So in a SOAP request, there will always be a header tag, and then there will be a body. So when we will start creating APIs, we will see what a header means and what a body means. But for now, I can just tell you that in the header section of a SOAP API, we have parameters which are related to maybe authentication, content type, like what type of content will be there in the SOAP request, how the authentication will be done in the SOAP request. So all those parameters are covered in the header section of the API, and in the body is the actual data. So in this example SOAP request, there is no header, and in the body we have a parameter name, and its value is Spain. So we are sending a SOAP request with this parameter name. And when we were studying about functions, API functions, SOAP functions, when we were discussing about the differences between SOAP and a REST API, then I said that the architecture of a SOAP API is that there will be a functionality implemented in the API, and there will be a fixed set of parameters and a fixed set of output parameters. So this is what I meant, like this is the function get country request. This is the function name, and this is the input parameter name, and we are passing its value as Spain. So what we expect is that when we send this input parameter Spain to the SOAP request, and the function is get country request, then we should get some response back about this country, Spain. So this is the request, and when we trigger this SOAP API, then this is the response which we are getting back. And what we are getting back in the response is Then this is the XML tag get country response, and there is another tag country, and in that we get four fields: name, population, capital, and currency. So this is just an example SOAP API where we are sending a request and getting some response back. So this is an example of a request driven architecture where we are sending a request to the consumer, and the service consumer is sending a response back to the provider. So this is the request and this is the response. Then the next thing is event driven architecture. And event driven architecture is of asynchronous type, where the provider will send some request to the consumer, but there will not be any response back to the provider. But before that, we need to understand what is an event. So request, we saw what is a request. Now what are the events? So an event is a small message that provides information about a business occurrence. For example, the creation of an order in HANA system, a newly hired employee in an organization, and these events are fired via push asynchronously to a broker. So what happens is, let's say in an organization there is like a HR system, right? And whenever a new employee joins the organization, then they will create the record of that employee somewhere in their HR system. So that is an example of an event. The event is some occurrence of a business process. So for example, when an employee is hired in the organization, that is an event. When an employee leaves the organization, or when an employee is terminated from the organization, that is also an event. When an employee is, let's say, promoted from one position to another position, that can also be another event. So all these examples are of an event. Now what happens is, whenever there is an event, then the integration, it is supposed to send the information of that event to the target systems. So let's say that again an employee is hired. Okay, now like since you are already like working professional, so whenever you join an organization, then after few days of joining, the organization will create a business email. Like for example, if you have joined TCS, then they will create your email something like @tcs.com, @infosys.com, like this, right? So when you are joining the organization, so that event, it needs to be sent, that information has to be sent to some system, and then that system will create the email address for you, right? So there has to be an integration between the two systems: the system where the employee is created or hired, and the system where the employee's email address is created, right? Now this type of integration, it is called as asynchronous integration, because we are just sending employees data. Let's say employees first name, last name, and employees maybe date of birth, we will send to the target system, and by using the first name and last name of the employee, the target system will create the email. Okay, now in this scenario there is no need. So, okay, when the email is created, then that's it, there is no need to send a response back to the provider, because the whole purpose of this integration is just to create an email for the employee. So this type of scenarios, they are called as asynchronous scenarios, where the provider will send the request, some information to the consumer, and then the consumer will just take the action what it has to do. But there is no necessity to send some response back to the source system. So these are called as event driven architecture. And this is another example of an event driven architecture where we are creating a product 1ST-1000. So when this product is created in the source system, then the information of this product, it needs to be sent to other, you know, systems, like for example the warehouses. So for example, if a product is created, right, but if that information is not sent to database or to warehouses, then the users, they will not know about the product which is created. So whenever a product is created, that information should be sent to the target system so that the users are notified about it. But there is no need to send any response back to the source system where the product was actually created. Okay, so these are the two types of architectures, request driven architecture and event driven architecture. Any doubts or any clarifications before I move forward?
No, Abhishek.
No, okay. I was just checking if like I lost connection or what. Okay. Fine. So yeah, in the event-driven architecture, there are two variants. One is the pull variant and the other is the push variant. Now let's say that there is a provider in this diagram, right? On the left hand side, there is an event provider, and on the right hand side, there is a consumer. And in between, we have an event mesh, enterprise bus event mesh. So the event-driven architecture, it's a software design pattern in which decoupled applications can publish and subscribe asynchronously events via an event broker. So event broker, we will see what is an event broker. An event broker is a modern message-oriented middleware, for example, service mesh. So whenever we are designing an API, right? So as I said, whenever we are designing an API, there will be an provider and there will be a consumer, and the communication between a provider and a consumer will happen through event mesh or a service mesh, which is provided by SAP. So let's say what happens is in the pull variant, and let's say there is an event, right? So this pull variant is part of event driven architecture. So there will be an event. Okay, so there will be an event which is like number one in this diagram, and this will send some information. Let's say a product is created or an employee is hired. So this message, it is sent to the event mesh, and in the event mesh we have two things. One is the topic and the other is queue. Now what happens is when this message is created by the provider, then it reaches the topic. Now what is a topic? A topic is just a destination for event. Whenever an event is triggered, then it reaches to a topic in the event mesh. And after that, this topic, it sends this message, the same message like it's shown by point number two, to a queue. And now what is a queue? A queue is just a place again to store the message, right? So when a message arrives on the topic, then it is pushed to a queue. And then this message lies in this queue. Now there are multiple queues in an event mesh, queue A, B, C, D, like this. So a message will arrive And similarly, there are multiple topics also. So a message, it will come to a topic. From there, it will go to the queue, but the message will remain at this queue. And then the consumer, it will pull this message from the queue. So what will happen? You can consider this like a schedule. Let's say the consumer, it will try to read the message from the queue in every 5 minutes. So in this type of setup, obviously the consumer will not know if there is a message in the queue or not on its own. So what the consumer will do, it will try to make a call to this queue. It will try to read the message from the queue in every 5 minutes. Just 5 minutes is just an example. It can be anything every 1 minute, 2 minute, depending on the settings. And then it will pull the message. It will read the message. Now, because the consumer is reading the message, it's like pulling the message. So this is called as pull variant. And when the message is read by the consumer from this queue, then this message is deleted from the queue because this message has been read by the consumer now. So there is no need to keep this message in the queue or in this entire event mesh. So it will be deleted from the queue as well as from the topic. And then that topic and queue, it will become empty and they will be available to read the next event or the next message. So this is the pull variant. Is Do you have any doubts in this, like why it is like functions like this, or what is a queue or a event? Then we have a push variant. So what happens in a push variant is, again, the starting structure will be the same, that there will be an event provider. It will trigger an event to this event mesh. So one is the event provider, two is that message which is triggered by the provider. And then again, it will go to a topic in this event mesh. From the topic, it will go to the queue. Again, this is also same. From this queue now, then there is something called as webhook. So now what happens is, in the pull variant, what was happening is the message was coming from the provider to the topic and then to the queue. And the message was lying on the queue and it will remain there till the time the consumer will read that message. Till that time, the queue will be occupied. After that, like there are like advancements in the technology. So now the push variant came. So in the push variant, what has happened? SAP has created a webhook in the same event mesh. And what is the function of this webhook is, as soon as the message comes on the queue, the webhook will read that message and it will push that message to the consumer. So the webhook, it will not wait for the consumer to read the message, because obviously the consumer does not know at what time the message is coming, because it's an event, right? An event can happen at any time. It will not happen at a fixed time or a fixed schedule. For example, if let's say an employee is getting created in the source system, so I can create the employee at any time in my like working hours. Whenever I am working, whenever I'm hiring that employee, at any point of time during the day, I can hire the employee, right? So there is no fixed time or a fixed schedule for an event to happen. It can happen at real time randomly. So when it happens randomly, the message will come on the topic and then on the queue, right, at that particular time of the day. So the event consumer, it will not know that the message has arrived on the queue. So what the consumer does usually in a pull variant, that they will try to read the queue in a scheduled manner, like every 5 minutes, 10 minutes. So for that 10 minutes, the message will stay there on the queue, and for that 10 minutes, it will keep the memory space occupied. And in some scenarios, let's say when the consumer is trying to read the message, then there may be some technical error, right? And then the message will again stay there. So then what SAP did, they created a push variant, and in that they created a webhook. So now the webhook, it does not wait for the consumer to read the message. As soon as the message arrives on the queue, it will push that message to the consumer, right? So this is called as push variant because the event mesh is pushing the message to the consumer. And the benefit of this push variant is obviously now there is less time. Earlier, when the event comes, then it waits for the consumer to read the message. So there is a delay of every 5 minutes or 10 minutes. But now everything happens almost instantly. Like the message will come in the queue, and then immediately webhook will push the message to the consumer. So within a few seconds, everything will happen. So this is one great advantage of push variant over the pull variant. Now there is another way of operating mode in event driven architecture, which is a combination of pull and push variant. But before that, webhook. So webhook, as I explained, that what it does, it reads the message from the queue and pushes it to the consumer. So a webhook is an HTTP call. It's an HTTP post call that occurs when a change in state is made. So a change in state means a change in state of the queue. Let's say a queue was empty and then a message arrived. So its state has changed. So as soon as there is a change in state, the webhook will read that message and pushes it to the consumer. So webhooks are used, as I said, for real-time notifications. So there is absolutely no delay. Everything happens within few seconds. As soon as the event is triggered from the provider, everything happens almost instantly. So the consumer, the target system, it can be updated immediately. So as soon as an employee is hired, the first name, last name of that employee, it is immediately sent to the target system, and then they can create the username, email address. In the context of the SAP service mesh, the webhook URL is used when subscribing. This allows the service to know where to send the message with the subscribed topic. So yeah, more or less it's the same thing which I explained. And the next thing is the combination. Now, combination of request and event driven architecture. Now we know like what is a request driven architecture and what's an event driven architecture. So APIs, either they follow a request driven architecture or the event driven architecture, but there can be some scenarios like there is an option where we can implement a combination of both request and event architecture. So what happens in the combination is that again there will be an event provider and it will trigger an event to the event mesh, right? So first I'm telling you about the event driven architecture. So in the event driven architecture, the message will be triggered to the event mesh. It will go to the topic, then to the queue, then webhook will read the message and it will send it to the consumer. This is the event driven architecture. In addition to this, flow 1, 2, 3, 4, 5, 6, what this consumer can also do, instead of waiting for a webhook to send the message to the event consumer, what the consumer can also do, it can directly read that message from the provider, right? So the whole point here is that the message which is created in the source system, that information needs to be sent to the target system. So for that, one way is this event driven architecture where we use event mesh. In that we use topics, queues and webhooks, and then they send the message to the consumer. Or the other way is where the consumer itself will read the message from the provider. So it's a combination, right? The combination is like the event, and then the consumer is sending the response back to the provider. As soon as the message from the webhook arrives to the consumer through the event driven architecture, the consumer will send some response or data back to the provider. So this is a combination of both request and event driven architecture. But again, it depends on the business scenario. If you want to implement a request architecture or an event driven architecture or a combination of both, not it is not mandatory to implement all the scenarios. It depends on your business requirement, what your business need is, and according to that, that particular scenario is implemented. Any doubts so far? And again, like I keep mentioning this almost in every class, if you are again planning for certification, then again, this architectures, API architectures, they are again an important topic. You definitely get some questions from this topic, request driven and event driven architectures. So yesterday I was showing you about some predefined integrations which are provided by SAP. But at the same time, there are some predefined APIs also. Yesterday, I missed to show you that. In the Discover tab, we have two options, integrations and API. So yesterday we saw integrations, and in the Discover tab, there were 6 packages. And if you click on APIs, then we will see a set of standard APIs which are provided by SAP. As of now, there are this 256 APIs, and because it's a trial account, so we have 256 APIs. But if it's a like a real account, then there are a lot more APIs than this. And if we open any service, then again it's the same thing. We will see overview, what is this API about. Then we will see some artifacts, and in this artifacts we will see more APIs, and these are all the APIs. And it will also tell us whether it's a REST API or a SOAP API. The type it will tell, version it will tell, and then there is an action tab where we can just copy it to our system. And if we click on a particular API, then it will give us this screen basically, and this we will see in detail, because when we will create the API we will also get a similar screen. We will see a data set, requirements, and we will be able to trigger the API from here. But when we will create the API, then we will see this in detail. Okay, so these were the topics actually for today which I wanted to cover, the architectures. And because like the topic was entirely theoretical, so I have just kept one topic for today, so that it's not overloaded for you. Like, not, I don't want to share too much information in just one session.